Okay, good day and welcome everyone with the beginning of a new update of a new package of only two new videos, which are part of the Cisco CCNA 200-301 exam preparation series. My name is Sajjad Ghafouri again from the III Networking channel on youtube.com, and this is the new update of 40 new questions that we will discuss and solve in these two videos. Each video will contain 20 questions only, and these are, you may know or not, are part of the exam preparation series regarding the CCNA 200-301 exam, that you might need to study that series before entering the exam, because they will review the topics, the knowledge, the protocols and technologies that you have studied along inside the complete course of the Cisco CCNA, whether you have studied that with me in this channel or with another resource or course. Okay, so starting with this one, question number one will be refer to the exhibit. A packet is being sent across R1 to this specific host. To which destination does the router send the packet? So we need to know the next hop that will R1 take or decide to reach or to route to, if the destination was this specific host. Since it's a host, then it should be /32 or such. And let's see what we can find here. This is a static default route. Leave this one, and I can see that there is a 172.16.30/24, so 314 is included, so this one is a possibility. And we also have another one which is 172.16.30 but /28. /28 will give me 16 total host minus 2 IDs. Then I will have 14 valid IP addresses starting from 172.16.31 up to 314. So 314 is part of that specific range of valid IP addresses, and I have 207, 207, 207 till the end. So all of those will not be useful to route to this destination. Only these two. So between these two, the competition will be between a static route who has an AD of 1 and an OSPF who has 110. Who will win? The one with static with the less value of static route. Yes, but that will be step 2. Step 1 will always be the longest match term, the most specific subnet mask that matches the same subnet mask of the desired destination. And since the desired destination is a host, so it has a /32, so the closest to 32 is the more specific. Who is the closest to 32? Actually, it's 28. So step number 1, look to the subnet mask, pick the longest match term. Only then, after that, in step number 2, you should look to the routing protocol and differ the AD value. So step number one will be the longest match term, only one, because I have a 16, 24, 28. So 28 will win. There is only one route to 28, so I will pick that 20 route. No problem, despite that it has OSPF, which has a much higher numerical value in AD compared to static, but I still will choose OSPF. So in OSPF, the next hop will be serial 001, heading to the IP address of 207.165.200.254. So serial 001 with this same IP address will be answer C for question number 1. Question number 2. Which goal is achieved by the implementation of a private IP address? Okay, this allows servers and workstations to communicate across public networks. No public networks, no WAN, no internet using private IP address. No, no, no. Provides a reduction in size of the forwarding table on network routers. No, this is summarization. Okay, and summarization is part of the IPv4 design, but not the private IPv4, not in this way. Okay, allows communication across the internet, no internet. Okay, and provides added level of protection against internet exposure. Is that correct? Yes. Imagine if you are using a public IP address to your host, to your end device personal computer, and that public IP address of your personal computer is traveling through the internet. There is a packet through the internet that carries your public IP address, which should be a personal. Actually, it's being carried and cluster clear to all the people around the globe as a source IP address of a packet that you have sent to the internet, a request or whatever, or a file that you are sending, or traffic or a multicast that you are uploading, streaming this way. So how many thousands of peoples or hackers or companies or ISPs will be able to know that your personal IP address is this specific IP address? So they will be able to reach you much more and much less secured than if you use the private IP address that will be natted on the edge of your ISP before leaving the network and going to the internet. So yes, security, privacy are extremely important, and they are part of the IPv4 addressing and usage. Question number 3 will be referring to the exhibit. A network admin assumes a task to complete the connectivity between PCA and the server number A. The file server. Switch A and switch B, I would need a dot here. Switch A and switch B have been partially configured, so more config is needed with these VLANs 10, 11, 12, 13. What is the next step in the config? Okay, let's see. If there is no router here, then these two devices, since they are end device, both of them should be accessed to a VLAN, and both of them should be accessed to the same VLAN. So because there's only a layer 2 connectivity here, no multi-layer switches and no routers. So let's see. Switch A says that these VLANs should be created 10, 11, 20, 13, 12, 13. Okay, I agree. Interface gigabit Ethernet 01, which is this guy here. It's trunk, should be trunk, must be trunk, because it's sending or passing multiple VLANs. Switch port trunk allowed VLANs 10 to 12, so only 10, 11 and 12 are the VLANs that are being really allowed to pass this trunk interface, whereas 13 it's not mentioned, and thus 13 will never be able to go through or from that interface. Okay, interface gigabit Ethernet 04, this guy that should be accessed. Yes, it's accessed but on VLAN 13. That's unfortunate because the VLAN 13 frame will stop here. It will not cross this interface. Maybe we should change the VLAN of PCA, but at the same time should match the VLAN of the file server. Okay, in switch B, the same config. There is an Ethernet 01, gigabit Ethernet 01, this one, and it's trunk without any further command, so it's trunked for everything. Okay, so VLAN 13 might pass here as well. Interface gigabit Ethernet 03, this guy is accessed on VLAN 13. So both of them matches the same VLAN, both of them are accessed. So VLAN 13 is the one that should win this topology. VLAN 13 must pass the entire path, and it will not pass only here because VLAN 13 is not added to the trunk allowed command, so we must add VLAN 13, as simple as that. So add PCA to VLAN 10, no. Add VLAN 13 to the trunk link between switch A and B, yes, that was I was talking about. Add a router on a stick. I have no multi-layer device here, no layer 3 device here, and add PCA to the same subnet as the file server. It is 010.120/23. It is on the same subnet. Okay, you are not adding something new, so it's only B and will always be only B for that question. Question number 4. When you use the WPA2 pre-shared key config in the wireless LAN controller, what is the minimum number of characteristics to create the first passphrase, the password that the pre-shared key will be extracted from? 8 digits. Like when you create your home router password, it requires a minimum of 8 digits to create the password of the access of that router, that home router. Okay, question 5 says refer to the exhibit which outcome is expected when PCA sends data to PCB. So there will be a frame traveling from PCA to PCB. The switch rewrites the source and destination MAC with its own. No, if the source and the destination MAC address of frame were the same of a same device, what will happen to the frame? Will it stick forever? No. B, the source and destination MAC addresses remain the same. Since there is no router here, then yes, they will remain the same. The source MAC addresses change. The source MAC address will never be changed alone, at least the destination as well. The destination MAC address is replaced with Fs, yes, but if there was a lack of ARP or MAC table entry, and I have no idea here about the MAC table, so I will not assume D. So I will choose only B for this question. And I hope that you do agree with me. An engineer needs to configure LLDP to send port description TLV some values regarding the port description between two switches that are using LLDP. Which command should be implemented? LLDP port description, yes, but in the user mode, the privilege mode, no, it's a config. LLDP port description enablement, yes. In the config mode, yes. LLDP port description in the line, no. Not in the VTUI, no. LLDP port description inside an interface, no need. Enable that globally because the LLDP is a global config, not per interface, not that way. So question 7, which guy will become the root bridge? The lower or the lowest bridge ID. And the bridge ID, as we have always said, is a numerical value that contains two parts. The left part will be the root priority, PRIORITY, and the right part will always be the MAC address, the system MAC address of the switch. So which one of you has the lowest priority? 32-ish, the default, 30,000 lower, 30,000 as well, also lower, and 32-ish. So not you, one of you two guys. Okay, but both of you have the same priority, so I will go to the tiebreaker, which is the second numerical value, the MAC address. Which one has the lower MAC address? B's are lower than C's. We know that because it's from 0 to 9, from A to E, 0 equals 0, and from A to F, and F equals 15. So B comes before C, and B has a lower numerical value. So switch 2, this guy will be the root bridge when the election happens or occurs. Question 8, refer to the exhibit, and this is the exhibit. What is the next hop for the host 10015? I have 10013, but it's specific, so it will only be .3. 10010/24 could be 10015/32. Yes, and definitely yes, because it's the same one and it's a host. So it's a host route because it's /32. So I will choose this one. And the next hop is 10015. 10015 will be the correct answer. And I believe so far those 8 questions are really simple. Nothing tricky, nothing outside the scope of the course that we gave. So it really makes sense. When an active router in an HSRP group fails, which router or what router assumes the role and forward buckets? Means who is the backup guy here? In HSRP group, the backup guy is called the standby router. So if there is a standby, pick that one. If it was a VRRP, then the master is the main one and the backup router will be the backup one. It's obvious in VRRP. Okay, question 10. An organization secures network with a multi-factor authentication application using that authenticator club on the employee's smartphone. So this is like when you log into a website in that it's part of your network or a server in your network. First you'll have to hit or to enter or to give a password to that server or service in your network. And the second step will be, wait a minute, I will send an authentication code to your mobile device. Give authentication from your mobile device. What will happen? How is the application secured in the case of a user's smartphone being lost or stolen? Okay, so that guy can authenticate or de-authenticate when the second factor authentication occurs. The application requires the user to enter a PIN before it provides the second factor. This could be enabled. The application challenges a user by requiring an admin password to activate when the smartphone is rebooted. I don't think there is such an option in the applications nowadays. The application requires an admin password to reactivate after a configured interval. That could also happen because maybe you like to make it every week or every month. You should change the application authentication step, you should change the password that is installed in your mobile application, and since it was stolen, then you can reinstall and re-authenticate your new mobile phone. So this can happen. The application verifies that the user is in a specific location before it provides the second factor. I don't think so. So it's either A or C. Let's go with A because it's more popular. The application requires the user to enter a PIN before it provides the second factor. So it will send the PIN to the mobile device, and from the mobile device you should take that PIN and inject it in your web browser, just like when you log into Amazon.com. Yes, so that will be A, if I'm not mistaken. Okay, question 11. Refer to the exhibit. What action establishes the OSPF neighbor relationship without forming an adjacency? So this is show IP OSPF interface. It's up. There is an IP address in area 1. And this is a process ID, a router ID. It's a broadcast network. Okay, there is a designated router. That makes sense. No backup designated router. Why? There is a time interval of 10, 40, 40. So these are the defaults. There is a hello that will be sent. On the other side, there is a same interface. There is an IP address in area 1. Okay, so they are matching, no problem. There is a process ID I don't care about, a different router ID that I don't care about, the same network, so we agree. There is a transmit delay. There is a designated router of another one, and no backup designator. There's a mismatch in the designated router. We have a problem here. So they are not communicating, and thus they are not exchanging the same designated router. Why? Because the hello interval here is 20, 80, 80. So there is a hello timer mismatch, and thus they will not communicate. So we would need to modify the hello interval in question 11. Question 12 says, dear, an engineer booted a new switch, okay, and applied this config via the console port, okay. Which additional config must be applied to allow admin to authenticate directly to the enable privilege mode, which is this one, via telnet using the local username and password. Let's see what did he configured first. This host name is R1. It's a switch. You are configuring as R1. There is an interface that has no switch port with a config with an IP address, so it became a layer 3 port. Line v2i login enable. Good. So we will able to log in remotely, but directly without a username or a password. So A, username admin. There is no such command in Cisco. There is nothing called username admin and hit enter. You must give the password as well. Username admin. This is a mistake. Username admin secret pass 1234. Inline v2i enable login local. Enable secret pass. This is correct, but this will not log in directly after hitting the username and the command and the password after typing those remotely via telnet, because telnet is enabled here. This will not log you directly to the enable privilege mode, because the enable privilege mode is protected with a secret. This will log you directly to the user exec. So we will need to remove that line. So this will make you false and faulty, and this one is correct. A username with a privilege, a line v2i, a login local, without mentioning the enable secret. So this will allow you to log in directly to the enable privilege mode. 13 says, refer to the exhibit. Which switch will become the root? Okay, anything mentioned about priorities? No, only max. So let's see. OC is identical, and E0 and 0E the same level, so it's identical. So I will have to compare these. 38 plus 0 plus 36 plus 75, that will give me 60 and 14, 74 plus 75, that will be 149. Okay, 15, 22 and 05 means 5 and 97. That will give me 37, 42. 97 plus 42 will be 99 plus 40, 139. Okay, 15 plus a and 1. A gives the numerical value of 10, so that will be 11 plus 3 and c. Okay, so a gives 10, b gives 12, c gives 11, c gives 12, D gives 13, and E gives 14, F gives 15. Okay, no problem. So 3C, 3 plus 12 will be 15, and 9 plus 13 will be 22. That will give me 26 plus 15, 36, 41. 41 plus 22 will be 61, 63. Okay, the last one will be 18 plus a1 is also 11, b3, so that will be 11 plus 3, 14, and 19. 18 plus 11 will be 29, 29 plus 14 will be 39, 40, 43, 43 plus 19 will be like 42 plus 20, so that will be 60. So this one is the lower numerical value in the MAC addresses, which is the fourth one, which is switch 4. So I will pick switch 4 because there is no calculator in the Cisco exam. Okay, question 14. Any chance to finish that? An engineer is configuring NAT to translate the source subnet of this private to this, to any of those three. 1, 2, 3. I'm sorry, this is 31, not 31. Which config should be used? Okay, IPNAT pool, my pool, so this is the public one, or should be the outside one, which gives from 31 to 33. The prefix length is 30, so this will be like /30. Route map, no need for route map at all here. IPNAT for the outside, guys. IPNAT should always be for the inside. Okay, IPNAT pool, my pool, has the same pool, same prefix length, an access list that is expressing the private pool, no problem. Okay, /24, I can see that. IPNAT for the outside, rejected. IPNAT pool, my pool, this one the same pool, and an access list one expressing the same thing. IPNAT for the inside, which is sourced from access list 1, and translate that for the addresses inside the pool that is called my pool. An interface inside, an interface outside, and C currently is the best one to choose. If there is D, then I believe D might be more specific, but there are only 3 choices here. An office has 8 floors with an approximately 30 to 40 users per floor. What command must be configured on the router SVI, switch virtual interface, that we did a lab on in the end of the CCNA exam complete course, the English one? Okay, so which command must be configured on the router's SVI to use address space efficiency? Actually, the question means design an IPv4 block that will cover the entire office. So the office is of 8 floors. Each floor has a maximum of 40 users, so that will be 320 hosts. If we use the subnet that is /24, that will give me 254 valid IP address. If we use /23, then that will give me 510 valid IP address. So this will be enough and exceeds. So this is /16. No, not at all. This is a big waste. This will be /23. Yes. No, what are you doing? No. Okay, this will be /25, which gives 128 sub IP address. No, and this will be /27, extremely not efficient. So B. Yes. I got thirsty. Okay, question number 16. Which device performs stateful inspection of traffic? Who does inspection in the network? Security devices. So is it a switch, an access point, or a controller? No, it's a firewall. Okay, unless you have an IPS or an IDS or an NGFW. What criteria or which criteria is used first during the root port selection process? If I have a switch and it has multiple ports, what is the first thing that the switch will lock when it elects one of its ports to become the root port? This guy, or this root port, should lead me to the closest path that will reach me to the root bridge. So the local port ID, no. The lowest passcode to the root bridge, yes. The lowest neighbor's bridge ID, I don't care about the neighbor. The lowest neighbor port ID, I don't care about the neighbor. So it will be the port that will lead me fastly and shortly to the root bridge. That will be called the root port in my device switch. Router R2 is configured with multiple routes to reach this network from R1. What protocol is chosen by R2 to reach the destination? Is it eBGP that has an AD? See, both of them have the same subnet mask. Will it be eBGP that has an AD of 200? Will it be static that has 1? Will it be OSPF that has 110? Or EIGRP that has 90? It will be the lowest, which is static, so I will choose B definitely. If there was static, static will always win. Okay, unless the longest match turn have another thing to say. Okay, 19 is a DND. Let's compare the device management from the left into the device management sections on the right. The DNA versus the traditional. Who uses SSH terminal? The traditional guys. The terminal window. Okay, manage devices on per device basis, box by box. The traditional. Monitor the cloud for software update. The DNA. Security is managed near the perimeter of the network with firewalls, VPNs, and IPS. The classic traditional way. Use the CLI templates to apply consistent config to multiple devices at an individual location. Multiple devices. Good. Which is this one, and uses NetFlow to analyze potential security threats throughout the network and take appropriate action on that traffic. The DNA guy. Okay. By the way, the DNA does also use the SSH to log into devices. Sometimes it can use that. I'm sorry, that was the... Yeah, the APIC. The APIC EM does that. I believe the APIC does that. So it might be used as well. Okay, drag the description of IP protocol transmission from the left into the traffic types on the right. TCP and UDP. Sends transmissions in a sequence, the TCP guide, to ensure no loss of traffic. Transmissions include an 8-byte header, that will be the UDP guide. Transmit packets as a stream, one shot, UDP. Transmit packets individually, as we said, in a sequence, TCP. Uses a higher transmission rate to support latency sensitive application, this annoying guy. Uses a lower transmission rate to ensure reliability. No, 1 minute. This is tricky. This is tricky. No, 1 minute. No. The guy that ensures reliability is TCP. UDP will never ensure reliability, so I will have to give it this one, which is higher transmission rate to support latency. If you have another opinion, please inform me below in the description of this video regarding question 20 and all the other 20 questions that were mentioned or discussed in this video. That will be at the end of this video, and in part 2 we will also discuss another 20 questions. Thanks a lot for watching. I hope that it was beneficial for you and good enough to make use of, and I hope to see you in the upcoming video. Goodbye.